Hello. Hey everyone. Hi. Good evening. Yeah. We've all come together for yet another NASSCOM FAYA Port 80, but this time it's a bit special because this time we are collaborating with Google for developers as a two-part series. So this is what you are going to see here today is part one of the presentation, and we have a speaker here. And we have a lot of things planned for the second part, the concluding part. And I'd like to welcome you all to the floor of madness, to FAYA's floor of madness, where you can go crazy with all the conversations regarding tech. And before we begin, let's take a look at what the tech world has in store for us right now. And I'd like to invite Michelle to take over.
Thank you. So hey everyone. So AI is the new hype, right? That's why we have this firepot data now. And let's start with a lot of AI stuff. Now, Llama 3 has been released. Now this is an open source model by Facebook or Meta, if you want to call it, which gives GPT-4 level performance for an open source model. Now this has more context window and like GPT performance in open source world. Next. We have GitHub CoPilot. Now, what is the difference between GitHub CoPilot and GitHub CoPilot Workspace is that GitHub CoPilot is mainly designed for individual coders, like the solo coder who just codes. Now, the workspace GitHub CoPilot Workspace is designed for a group of coders, where everybody can collaborate, ideate, and create code, create new products and stuff. So, next one. Now you can just take output from Gemini just from the Chrome browser by using @Gemini symbol. Now
Here's
this
how
is
to
a demo
quickly
video
start
of
your
it.
chat with Gemini from the new Chrome shortcut on desktop. To get started, click
So
into
just
the
give
address
that
bar
symbol
and type
and write Gemini, and you can write the prompt,
Then
and this will
write
give
your
you output
prompt to
for it.
start the chat. Chrome will automatically direct you to gemini.google.com, where a detailed response awaits.
So that's how you can access Gemini the easy way. Next.
Here's how to quickly start your chat.
Now, 2-3 months ago, I have said that Rabbit R1 was going to be released in the same tech bytes, which I have like we said like 2-3 months ago. Now, Rabbit R1 has been released, and there's been interesting video by MKHPT. So, there are a lot of features which they plan to release have been released, such as you can book a Uber, alarm clock, and contact GPS, and all the stuff. You should really watch the MKHPT video because there are a few interesting stuff. Next. Now, Microsoft is creating new LLM. Microsoft, OpenAI is actually backed by Microsoft. They mostly fund OpenAI, but now Microsoft is creating their own LLM without the help of OpenAI. For that, they've hired Mustafa Suleiman. So, if you don't know him, he's been in the AI space for more than a decade. So, he created he sold a company, he created a company called DeepMind in Technologies, and that has been sold to, has been acquired by Google a decade ago in 2014. So, this guy has been really in the AI space since for many years. So here Microsoft hired him for creating a new AI called My.1. So that's the new LLM model name. Now next we have OpenAI partnering with Stackoflow, because there was also a meme which I saw in the Reddit, like Stackoflow was not able to beat OpenAI, so they decided to collaborate with OpenAI. So it was a meme because now most of the people don't use Stackoflow. Everybody uses OpenAI for resolving bugs. That's a more efficient way. So instead of Stack Overflow creating their own LLM, they just partner with OpenAI to create and improve ChatGPT. So everybody wins situation for both of them. Now next we have AI for James Bond. It's a funny title. I just gave it. So the underlying thing is that Microsoft plans to create an LLM for US intelligence agency, for example, CIA and FBI. So which is not actually connected to the internet, so their documents or their prompts cannot be, leaked or trained again by the model. So it's a closed model in the sense it's not connected to the internet. So that's LLM created by Microsoft for CIA FBI, but this is not similar to the previous model which is mentioned my.1. Okay, next one. Now, OpenAI is also creating a search engine. Instead of the problem with LLMs is that they can't give you factual stuff. No, that's the problem with LLMs because you can ask, 1 plus 1. That's a stupid question to ask for LLM because it takes a lot of computation power. And also searching real world stuff and news is not, not the not it's not what LLMs are designed for. But now OpenAI is creating a search engine that will, it is solving a problem where if you ask for ChatGPT to write a research paper underlying and also set it to like like say okay, I want to write a research paper and I also need to mention all the resources everything. And if you check the resources, there won't be any resources like that, or it will be invalid. So for like fixing that issue, they have created no OpenAI search engine, which here's one. The feature will allow as is, with citations. If it takes some from data from a website, it will cite the website. It's taken from this source. Okay, next one. No, it's in development. It's idea they proposed. Now, in the beginning, I said, AI is the overhyped stuff, right? But someone, disagrees with me because, video. Can I play the video? The only thing is that the person who disagrees with me is the former CEO of Google. Just a minute. Sorry for the technical issue. So the thing which I was about to show you is like it's announced but not released. Let it be. I need to come up something for the next 5.80, right? I mean this. So the main thing is that everybody's saying AI is hype stuff, right? But the person who disagrees is the former CEO of Google. So he says, AI is actually underhyped. Now I will show the video and he will be explaining the logic behind it. The only thing is that it takes time for the video to come up on screen. Fine.
First, I hate to tell you, but I think this stuff is underhyped. Underhyped. Not overhyped. Because the arrival of intelligence of a non-human form is really a big deal for the world.
And you think it's here?
It's coming, it's here, it's about to happen.
And please do read
it
the
happens in
subtitles over here.
stages. If you look at the,
How quickly, though? I mean,
well, we used to say 20 years, now within 5. Within 5. And the reason is the scaling laws for these systems are continuing to go up without any loss or degradation of power. So what happened was OpenAI in this generation invented this category. It was with their Microsoft partnership, they're going to spend $30 to $100 billion on this. Google invented it and then was a late arrival, now is in the game. I'm assuming the numbers are similar. You have other entrants that are incredibly interesting. So for example, Meta has just released a 400 billion model called Llama 3 in open source form, which allegedly is as close to GPT-4, which is from a year and a half ago. So the open source industry is following the closed source. The big winner right now is still NVIDIA. And the reason is that they have a virtual monopoly on the software stack between the hardware and the software that everybody's using. Well, first, I hate to tell you, but I think this stuff.
So that's the word from the former CEO of Google. And yeah, invest in NVIDIA.
Not NVIDIA, don't invest in NVIDIA. Okay.
No, this is a joke. It's good. Like, yeah, I mean, if you know, I have been like I like open source, and for the I never seen such like there are a lot of open source software, but it's good to see that ChatGPT 4 is closed out, but the open source world has just caught up with it. Okay, and also like less costly compared to GPT-4. The API cost is much lower, and the performance is almost same. And any other open source project, I have never like noticed this trend where the open source model is actually almost similar to the closed source model, and is also much cheaper.
Like, what do you mean by underhyped? Is
Uh,
people not aware about AI? Are they not using AI? What is this underhyped?
my mother only knows about ChatGPT. That's the issue. I think that I guess that's what is meant by underhype.
So actually people right now think like, oh, there are just like 3 or 4 models that is available and all these hype that is happening around with these models, and only there is less things that can happen with that. There are many people actually think like A right now is overhyped and nothing is going to happen in near future. So we have been hearing about this AI coming and changing automatic cars and all those things 10 years before also. Nothing happened till now. But right now, it is a time where we have to believe that it is not overhyped, it is underhyped, because the change that is going to happen is much beyond what we could imagine right now, and you will be seeing in next few years.
So that's it for this month's Tech Bites. Thank you.
Thank you, Michelle. That was enlightening, I bet. So, what I got from all of that was uh, they seem to be naming AIs after animals, right? Llama, rabbit. Okay. Uh, so animals. No, I'm not. I'm not here to speak about animals. Okay, let's talk about. Let's get back to business first. So, as I mentioned earlier, this is NASSCOM FAYA Potato's first association with Google for developers. We are collaborating with them on a 2-part series. So this is part 1. The 115th edition of FAYA Potato is part 1 of our association with Google for developers. And they've sent a big badass over here to speak about Gemini, Google's Gemini AI. And you might get a taste of what Gemma LLM can do as well. So let me introduce our speaker, Tarun or Jain. So Tarun is passionate about coding. He's an expert in everything AI you can think of, machine learning, all of that. He's written over 80 blogs so far on his coding journey. So you know he's big in this. And he would be presenting us with a demonstration of Gemini and a short demo of Gemma LLM.
Gemma, fine tuning.
Right. So, without further ado, I'd like to invite Tarun to.
Thank you for the introduction. So even I have few little bit of thoughts on the underhyped thing. So probably we can discuss it after my talk.
and probably there is much more to AI things. So talking about what my talk is about, first of all, I hope everyone are doing fine. All right. So my talk will mainly focus on there is data everywhere, right? You can find data in any platform, whether it is on social media, whether it is normal education, finance. Am I audible till the end? All right. So there is data everywhere, and it doesn't matter in which industry you are. The primary focus is collecting data. Now the thing is, if you observe large language model, if you ask domain specific question, like suppose if you have a gaming company, right? For a gaming company, you have lots of manuals. For each manual, you have little bit of shortcuts. Now, if you go to ChatGPT or any large language model, and if you ask, hey, this is my game app, and this is the manuals, and you are asking certain question, and it will be like, hey, I don't know what your gaming company is about. Now, you can think your game company was developed in 2022, and if you ask any question related your game to ChatGPT, it will be like, I don't have context related to what your data is about. So this is where there is a concept called retrieval augmented generation. So what retrieval augmented generation does is, it will connect your data to a large language model. Now, how does this happen? This is what my entire talk will be about. So before we start, I'll give a more detailed overview of what my background is about. So I work as a data scientist at a startup called AI Planet. So it's a Belgium-based AI startup. And apart from that, I'm also a Google developer expert in AI ML with NLP being my core concept along with TensorFlow and MediaPipe. So it's been around 9 months since I've been a Google developer expert. I've given more than 25 plus talks in this field. And apart from that, I'm also part of Google Summer of Code 2024 at an organization called Redden Lab. So I'm building a multilingual LLM. Multilingual LLM is nothing but large language model is good, but it needs to understand different languages as well based on your own data, customized data, not on general knowledge. So this is my project that I'm working on. So it's basically the normal languages like English, German, French. But the catch here is it is related to news data. This news data is from the Redden Labs. So you are building a multilingual LLM which can answer to these news questions. And this news questions is varying, like it can be in English, it can be in German, it can be in French, Arabic. All right. So past year, I was also part of Google Summer of Code again. So this is my second year. Last year, I was at the organization called CA Microscope. So this was mainly about imaging, like you are adding the support of 3D image for a medical images, where you can zoom each pixel values and you can see this on a real time. So these were the projects that I built for Google Summer of Code. And yeah, in my free time, I watch anime and I read manga. So let's talk about large language models now. So I'll just give a brief. Everyone knows what ChatGPT is, right? Is there anyone who has heard ChatGPT for the first time? Anyone? No, right? So everyone are aware of the concept called GPT, right? So what exactly is GPT? So GPT is a large language model which was trained on a GPT model. So GPT is nothing but generative pre-trained transformers. So by transformers, I don't mean this particular transformer. Rather, I mainly focus on this particular architecture which was developed by Google in 2017. The paper was attention is all you need. So the concept was very simple. Large language models basically is a language model. So language model is nothing but whatever text you have, it needs to understand the text, right? And when it comes to text, there are multiple edge cases that you can say. Suppose if you have a very large context, like this is Apple, right? This is Apple can also be a product. This is Apple can also be a fruit. How do you make difference between your Apple and this Apple, like fruit Apple and brand Apple, right? There is no context in these two things when it comes to a normal language model. This is where the concept of attention came in. Like what attention does is, it has the weight mechanism on based on the weights, it tells okay this apple based on your entire context, it will take the meaning. So it's focusing the attention on that particular keyword, right? So this is where attention mechanism came into the picture. So once attention came in, again there was the miscommunication between the language translation, right? Language translation is like, suppose if you have your data in English, how are you converting that into any other language, right? This kind of use cases is where transformers was initially developed, And the concept was you have two blocks. You have encoder block, you have a decoder block. And there is attention mechanism in between that, which we call as multi-head attention. But not to brag much about transformers, because this is not the main focus of my talk. But just to give you a basic understanding, everything in deep learning is all about transformers when it comes to large language models. Now let's mainly focus on what are the things that we need to focus on large language model, and why do we need RAG, right? Why do we need RAG in the first place? So now let's suppose you are going to GPT and you are asking a very basic question. So the question can be, what happened in yesterday's match, right? Yesterday's IPL match. Do you think it will be able to answer the question? No, right? It will give you some kind of response. It will answer, right? It won't tell you, hey, I don't know. It will give you something, and then it will tell, hey, my latest memory is still April 2023, right? But it will give you some kind of context. It won't directly tell you, I don't know, right? Ideally, whenever you are building an application, you need to have a chatbot that answers specific to the prompt that you ask, right? Now, if I am working on some kind of tourist place, right? I have a tourist website. In this tourist website, I want to give proper response to the user on whatever query he asked. So this is the query now. At what time does ISKCON temple open? So basically, what does the end user need, right? Whenever you ask this question, you should just add the time. At what time it opens in the morning, at what time it opens in the evening. So what exactly happened here? GPT gave me the response, but nowhere in the response I can see the time. So what is my end goal? As a user, I need the time. What is the morning time? What is the evening time? So this is where it hallucinated, right? So if you see the response from beginning to top, it said it varies based on the location. So ISKCON temple is not just in Bangalore, it's there in many places, right? So it just told it varies based on your location. Now, if I want to make my large language model return the response to the question and what I asked earlier, the prompt is same. At what time is temple open? But what am I doing? I'm adding the context above it, right? So what is the context? I'm giving the specific context saying at what time the temple opens, whether it is a morning time, whether it is in evening time. So whenever you give a context, along with context, if you give a prompt, the prompt is nothing but your query. It will give you the exact response, right? It will add little bit of intelligence. So this is what we need, right? Whenever you want to leverage large language model, the better is the prompt engineering. The better you write the prompt, the better results you get. But how do we write better prompt? There are different techniques. Yeah, I'll be connecting what this prompt is about with RAG. Why do we need this kind of prompt when it comes to getting this particular response? So before that, as I told, prompt engineering is the most underrated task when it comes to large language models. So if you want to get a better result, write a better prompt. So these are two different techniques now. I'm referring to zero-shot prompting, and one more is few-shot prompting. So zero-shot prompting is nothing but whatever you usually go and write, right? So suppose most of us have used GPT now. And the main thing what we do is we just directly go and write prompt. We never give them the context. Now the things is different. Now let's suppose if you want to create a LinkedIn post, you will tell, hey, this guy is the speaker and this is the event about, and it will give you the response. So that is your context, which is few shot prompting. And you can also tell few shot prompting to be in context learning. Now again, if I have to give you one more use case example for an e-commerce website. For e-commerce website, if you have a product, you want GPT to give a proper product details on that particular product, but it doesn't have the details. It can be the sweatshirt. Sweatshirt, it's not there in the product list, but I need to get the response to it. So this is where connecting your data to a large language model with a specific context is very important. So this is what RAG does, but let's talk about the limitations. So where are the issues that we need RAG to come in? So there are various issues that we have, and we already saw those issues in those two prompts. The first thing is it hallucinates. Now, what does it hallucinate? I told you, right? If I ask GPT to tell me what happened in yesterday's match, it will give me the response. But that response is invalid. This is what we call hallucination. Hallucination is nothing but whenever you get a response which is out of context or out of box response, This is what you refer as hallucination. Then second thing is knowledge cutoff. Now knowledge cutoff is nothing but if you ask again, same example, what happened in yesterday's match. So there is a knowledge cutoff at specific time. It can be April 2023. So whatever events occurred after that particular time, GPT doesn't have the knowledge of it. So this is one main disadvantage. And the last thing is, if you are building any application as a developer, you need to focus on domain. If you are in a gaming domain, if you have your car manuals, your gaming manuals, whatever query you ask, it should return the response from that particular manuals, not from a general knowledge. So you can take example of PUBG. So PUBG, it's normal. GPT knows about it. If you want to ask shortcut of it, it will directly have the general knowledge of it. So if you want to get specific response, which is contextually correct, this is where you need to pass the data that you have, not which is general. So in order to target all these three solutions, this is where we have retrieval augmented generation. And I'll probably answer your question now, where am I linking that context to RAG? So let's suppose you have a query. The query is again the same. The query is at what time ISKCON temple open, right? You ask that query. Now what you do is, a deep learning model doesn't understand a text. It needs to understand vectors. So this is where what you do is, whatever context or question you ask, it is getting converted into embeddings. Embedding is nothing but the vector form of your data or whatever text you are passing. So it has a semantic meaning based on which it is understanding what your question is about or understanding the language. So once you have the once you ask the question, the next thing is you are making it understandable to the model by converting that into the embedding. So once you have the embeddings, you have a special database which you call as vector database. So vector database, why is it different from normal database? I assume most of you are developers or might have come across SQL, right? SQL or SQLite. Basically, the example of SQL is you are just storing the data in the table format, right? Whereas vector database, it is storing the vectors, and these vectors has certain semantic meaning, and it has the ability to perform advanced search technique. Now let me give you an example. I am building a tourist place, right? I have a tourist platform. I am building a tourist website. So when I am building a tourist website, I am keeping in mind of 10, 20 places. For these 20 places, I have a proper data. It can be about the history of that place, it can be the timing of that place, it can be price, it can be XYZ. So in this tourist website that I am building, I have this kind of places. All these things will be saved in vector database. So whenever I ask a query, whatever is relevant to that query, you need to return the document. Returning this document which is relevant to the query is what you call a search technique, which Google is doing for a very long time, right? You just ask a query, it is giving you just SEO based whatever you have. So this is nothing but search technique. But in deep learning, we have certain concept like cosine similarity, and now in recent days there is one advanced search technique which is MMR, which stands for maximum marginal relevancy. So these are the search technique which can be done using vector database. So the main goal is whatever query you have, return the relevant documents to that particular query, right? So now this context, whatever is getting retrieved is that context which I passed in my prompt. If you looked at my future prompting prompt, add at what time ISKCON temple open. Above that, I add the context. So this is the context, this is the query, you are passing both of them to the large language model. And once these two are passed to the large language model, this is where you are getting the response. Now let's talk about, I can use that itself, right? Why am I even using this? You can do it for one prompt, you can do it for two prompts. Suppose if you want to build the application, getting the context every time is not a good idea, right? This entire process needs to be automated, where you are getting this context relevant to any query that user is asking. So you just want user to write a prompt. In the backend, your RAG will take care of getting the retrieved context, which is relevant. And this will be passed to the large language model above your or below. So it's like you're passing both query and context to large language model and you're getting the response. So in the overview, this is how RAG works.
How does the LLM work? Directly you give the query and give the response.
That's it. The normal LLM is just a prompt you're passing.
Doing the vector transformation. So when we are doing the vector transformation, what
benefit does it add there? I understand the flow, I understand the vector transformation, getting the retrieved context, but on top of the LLM, how does this work?
So top of like RAG, there are two components. The first component is retriever. The second component is generator. So generator is what is your large language model, which is separate. So generator will only come when you have your context. You are getting your context from retriever, right? So whenever retrieve context is, suppose you ask a question at what time ISKCON temple open. Yeah, that is your query. The context is, so when you ask this query, right, you need to get the context. That context is nothing but morning, what is the opening time, evening, what is the opening time. Where are you storing this data? You need to get this data, right, which is automated. This is just one example. Suppose I told you you have a tourist website. For tourist website,
So you consider yourself as the one who actually developed the tourist website, and you want to have your website intelligent to provide that data. Like they will be using a normal query as when ISKCON temple open, but that is the response should be from LLM, like with details and all those things based on that question. But there should be a context that need to be set in between within the data that is relevant for from your database.
this is entire RAG. Like RAG is nothing but two components, retriever and generator. Retriever will give you the context. This context is passed to the large language model, which will give you the response. I'll come to step-by-step process.
So normally, like in your website, you just want to have an LLM based chat. Okay, what will happen? A query comes in, you send it to the LLM, and LLM gives the reply. But LLM doesn't have the detail of those information. So you, as the website owner, you will maintain a vector DB.
Fine tuning is alternative of RAG. So now I'll go step by step. I'll tell you how vector database are storing your data in vector database. So which will make more sense to you.
Yeah. So there, that query is by the end user. This vector DB, as a web developer, you have the developer, you have set it up with the connection to the LLM.
Why is not the vector being used directly with the LLM? If I am the creator of the LLM and I know that, suppose
Okay, you have your LLM.
suppose I have my own LLM, okay, I know that like it would work much better by using the vector components. So why don't I use it along with the LLM apart, like or like separate as a RAG? Why is there a difference with that?
So there are alternative ways, right? Suppose if you want to use your data along with LLM, that's fine tuning, where you're teaching your model about your data. So you can't combine your vector DB with large language model, because large language model, you have to fetch your data. You can't store your entire context inside large language model. The reason being is you have context limit, right? If you have around 10,000 documents, will you pass all 10,000 documents to large language model?
This retrieved context, it will be in vector format or query format?
No, it will be in text. So it's like when you ask a question, right?
Okay, there may be a separate use case which I am missing, like later on.
So probably I'll go step by step. Now this is just the overview of how RAG works. Now we'll go step by step on how the data is getting passed into vector DB. Now let's come back to the basics. You have a YouTube video, right? YouTube video, there is a 10 hours of podcast. You want to ask a specific query from that particular 10 hours of YouTube video. So this is your external data, which is a YouTube video. And now you need to chunk your YouTube video. I'll tell you why you need to chunk. So when I ask a query from the 10 hours of podcast, the normal query that I'll ask is, what did X user tell about Y user? So out of the 10 hours, somewhere in some transcript is talking about that particular question. So do you think, are you supposed to pass the entire video, or just you have to pass a specific context? Right, so what you will do is, you will bifur your entire data into smaller chunks, so that whenever you have a long video or whenever you have a long data, you are not passing directly to a large language model. So why we are not doing this? Large language model has an issue of context length. By context length I mean, suppose an example of GPT, it has the context length of 16K. So if it exceeds more than 16K, that means it won't take that particular data. So each model has specific context length until which it can understand your prompt or the response that you are generating. So this is where okay. Okay, so once you have your YouTube video, you are creating a smaller chunk of that video so that whenever a user query is asked, only that specific chunk is getting retrieved, not the entire video, right? So once the chunking is done, the next step is you need to create the embeddings of it. Again, text is not what your language model understands. You need to convert your text into embeddings and then you need to store that into the vector database. Now vector database is where your embeddings will be saved. So the next time whenever you ask a query, you are doing the search technique. It can be cosine similarity, it can be MMR or anything else. So based on whatever search technique you do, you are getting that particular context. And how is this context getting retrieved? This is where we'll go step by step now. So there are three things. One is retrieval, second one is augmented, and third is generator, right? RAG. What is RAG? Retrieval Augmented Generation. So what happens in retrieval? A user is there, is coming to our platform, is writing a query. That query is getting converted into embedding. So we had the same diagram before. The only thing what we are doing now is we are going step by step. You are getting the embedding, it will look into the vector database, it will perform search, and it will return the specific document that you need. The document is your text, it's not query or embeddings. And here there is a value called K, right? In most of the available frameworks, there is a value called K. Now, why is this K very important? Now, let's suppose I ask a question, right? What did X person tell about Y person in a 10 hours long video? So there might be different chunks. How many chunk do you need to retrieve for that specific question? Whether it is a single chunk, whether it is two chunk, whether it is three, that is what K decides. And this is where if your data is very long, you define your K to be either from 5 to 10 if it is very small. Suppose if you have your resume, all right, if you have a resume, it's only one page. And if you are creating a chunk, hardly you will have 3 to 4 chunks. This is where your K value K will be 1. So based on your data size, you are defining what should be the K value that you need to give. And this is what will happen in retrieval, right? You ask a question, get the embedding of it, look into vector database, perform search, get the context, right? Context is very important. And once you have the context, you need to frame a prompt. So if you looked at my few shot prompting, I'm adding the user query. User query is there. Along with user query, I also want to add my context. So you need to define the template, right? You need to define a template where you can add your context, you can add the user query, and then is your updated prompt. So this is what happens in the second step, which is augmented. Retrieval is done, augmented is done. Same diagram, if you looked into the first diagram, I passed context and query to the LLM. We are doing the same thing. Whatever augmented prompt you have and whatever context you have, you need to pass it to a large language model. So the part of large language model is just to get the prompt and return the response. That's it, nothing else. So it won't do additional tasks. So the role of large language model is, even in GPT, right? You ask a prompt, you are getting the response. The same thing we are doing that in RAG. So the heavy lifting is done by vector database to return the relevant document. If the relevant document is not good enough, then your RAG has failed. This is where there are so many advanced retriever techniques which have come into the market or in the industry as of now. Few of them is keyword retriever. What we are doing so far is just a vector retriever. You are doing the vector search. There is keyword search, and most of the people who have worked with recommendation engine might have come across TF-IDF, might have come across something called as rank 25. So these are few keyword search algorithm. And then there is re-ranking. As I defined, there are total K value to be 4. Out of those 4, which one needs to be given the priority? This is where re-ranking comes into the picture. And there are few algorithms which have been built for re-ranking as well, which will re-rank your context and give the priority to which context is more relevant to the user query. So these are the few retriever techniques, and this is just the overview of RAG. Now, how do you implement this particular pipeline? There is a library which I have developed, which is Beyond LLM. This is the link for it. Bitly beyond LLM RAG. You can probably get the example code for it, but I'll go step by step on how you need to execute it. So this is the link, bit.ly beyond LLM hyphen RAG, which is RAG. All right. So this step is very simple. It's a Python open source project. You just have to import beyond LLM where you are adding source, and source is nothing but you need to pass your data, right? What is source? It can be PDF, it can be YouTube video, it can be CSV file, it can be any data. Then you need to have retriever. Why retriever? To get the document. Then generator. So basically your RAG is just two part, retriever and generator. Then we are using Gemini. Gemini is the large language model that we are using. There are two models that we need to use. If you look at the entire RAG pipeline, you have a vector database, you have an embedding model, you have a large language model. So embedding and large language model is where we will use Gemini. And for vector database, there are tons of open source vector database available. It can be ChromaDB, it can be VV8, it can be QRunt, which is open source. VV8 as a cloud version, and there is also Milvus. Now what you need to do is you need to configure your Google API key, and in order to configure your Google API key, you need to go to AI Studio where you can get your API key. So once you get the API key, the next thing is you need to set up your data. So source.fit here, just my example, I told I want to do query related to a YouTube video. I will pass the YouTube video. I need to define D type. D type is nothing but YouTube. If you are passing a CSV file, suppose you want to chat with your CSV file, pass the path of your CSV file and define D type to be CSV. If it is your PDF, add PDF and your D type will be PDF. Here is what you need to focus on. One is chunk size and one is chunk overlap. So you have a 10 hours of long YouTube video. You are creating a smaller chunk of it. Now there might be chances that whatever your second chunk is there, it should have some context from first chunk, right? From its consecutive chunk. So this size, what chunk overlap, like here I'm giving 0. 0 in the sense, whatever is there in chunk 1, don't pass it to chunk 2. If I'm giving chunk overlap to be 100, so what happens is, whatever last 100 tokens are there in chunk 1 will be passed in the beginning of chunk 2. Understood? Very simple. Chunk overlap is nothing but how many tokens are you supposed to use from previous token, right? Not vector documents. You are just splitting your document. Vector DB is not coming. Yeah. So very simple, I'll tell. Still you are just doing your data and what is the second step? Chunking. You are not getting into vector database as of now. We are just setting priority on how to do chunking. Chunking is very important, right? If your chunk is not proper, suppose if you just define 100, you are not getting the relevant documents in that 100 chunk. So better chunk size based on your data you write, the better context you get. So this is where chunk overlap is one of the major feature. Why? In most of the cases, suppose I ask the question, right? What did X tell about Y in that particular YouTube video? And that guy spoke about that Y person for 1 hour. So it's like it might be divided into 3 chunks. So you need to have some kind of similar or similar chunk between 2 or 3 values, right? This is where your chunk overlap comes into the picture. Usually you can define chunk overlap, but since this is a very small YouTube video, I've just added chunk overlap to be 0. So now you are only doing the 2 steps. One is get your external data, do the pre-processing, which is your splitting. That's it.
So here, like source data can be YouTube or on as CSV or Excel.
Anything.
And,
There are
and is it possible to connect to a table in a database and use it?
So there are different data loaders, what we call.
Yeah.
The data loaders, you have SQLite data loader where you can connect your SQLite and you
For
can.
example, if our data, that is, we have the entire data of the product and description, everything in our Postgres DB. So is that like from that database, there is a table that has all those data, right?
Yeah,
So,
this is where Postgres DB, as I told, right?
Yeah.
Vector database, you have Chroma,
Yeah.
you have VB8, you have Milvus. Postgres also have their own vector database.
Okay.
What you can do is, instead of directly using Chroma, you can use Postgres as your vector database
Okay.
and fetch data from there.
Okay.
So this is one possibility. When it comes to data loaders, There is one more service called Airbyte. They have tons of data loaders. You just have to use Airbyte, create your account, add your data there, fetch it. There is also Confluence by Atlassian,
Yeah.
where you can add multiple. Best example, Drive. In Drive, you can add your CSV file, PDF, get the data from it. So this step is only to get your data. That's it. As of now, Gemini is free. It was supposed to be till May 2, but they have extended till May 14. So you can directly go to ai.google.dev. You can get your API key and you can play around with it. Uh, Currently till May 14 it's free. Then it will be like pay as you use. The number of requests you do, you pay like that. So same thing what OpenAI is doing. So the number of requests you ask, it will charge you a few dollars, 0.0 something. Alternative for this, you can use Gemma, right? Gemma is open source. Instead of using Gemini as your LLM, you can use Gemma. We have the support of Hugging Face, Olama. Olama is where you're loading your model locally, right? Hugging Face is where you're just using their inference and loading the model. And you can use any open source models as well. So open source model, the only issue with them is the quality, right? If you ask a complex question, Gemini and OpenAI, they can frame up the answer and the inference is good. Why? It is running on their servers. When it comes to open source model, you are running it on your system. And your system is not that much of capable. So it will take too much of time in inferencing. If you have GPUs, spin those servers, get the response. But it's possible to use open source as well. So we have around 20 different D types. Like it can be your Markdown. Markdown is nothing but what usually is there for GitHub. Gitbook is there, PPT is there, document, PDF, CSV, URL. If you want to chat with any website, right? YouTube. So there are others as well. Probably you can check. What? Yeah, there are so many data loaders available. Like apart from beyond LLM, there are libraries like LangChain. Currently, since we have built it, we have limited number, but there are so many other things as well. As of now, I guess we have around support of 10 to 15
types of data.
D types. It can be PPT, document, Markdown, PDF, and all. So if you look at few libraries like Llama Index and LangChain, they have the support of Confluence, Airbyte, uh, Drive, and all those things. So D type, it's like just data loaders. So now comes the very, very important part. Here you need to define your embedding model. In our library, we have made Gemini, LLM, and embedding model to be default. Probably I'll also show you a few examples where we are defining embedding model. So what happens in auto retriever is you need to pass your data, which is your chunk. You also need to provide your embedding model. Here the embedding model is default. As you can see here, embedded model by default is Gemini. So embedded model is nothing but an additional argument. Then type is normal. Now what is this type? I told you there are advanced retrievers available now in most of the libraries. The advanced versions are like hybrid search. I told you about keyword search where you are doing keyword TF-IDF rank 25. So once you do that keyword search, if you want to combine with vector search, which is doing cosine similarity and all those things, if you want to combine these two, there is a method called hybrid search. You can just mention type to be hybrid. You can mention type to be normal. Normal is nothing but just vector search. Then you can do re-ranking. Now what is re-ranking? You have K. You have 4 K values, right? Out of these 4 documents, how do I need to re-rank? Which is the priority? So there is a thresholding what happens in re-ranking. So based on the threshold, you are re-ranking your context which is getting retrieved. So this is where K is very important. Type, if you want to use, if you want to build advanced RAG pipeline, you can define type to be re-ranker, which is cross re-ranker, which is using open source. Then data, whatever is getting passed from here. Now once you have the retriever, you need to pass it to your generator model. So what generator does? Generator need to take your large language model, it needs to take user query and whatever return documents you are getting. That's it, only 3 things. One is your question. Question is nothing but only user query. If you see, I am not passing any context. who will pass the context? This retriever will get that context. And your query is what user writes. And again, if you see here, LLM by default is Gemini. So here, instead of question and retriever, there is one more argument called LLM. If in case you want to use open source LLMs, you can define that. But here for LLM, Gemini is default. And once you define your generator model, there are only two models. One is your retriever model, one is your generator model. Once you define your pipeline, you just have to call it. So what call will do is it will return your AI response. So suppose what tool is video mentioning about. So there is this particular video which we are talking about Jupyter. This will tell you what is the Jupyter tool about. So this line pipeline.call is where your AI will return a response. Then this additional thing which we have added in our library is you are getting a response. Well, that is good, but is that response valid enough? Is it true? How do you evaluate them? This is where most of the libraries are still working on it. Like, how do you evaluate your large language model? This is where we have developed a RAG triad. There is also a library called TrueLens. So let me tell you what this RAG triad is about. Triad is in the sense we have context relevancy, we have answer relevancy, we have groundedness. So context relevancy is nothing but whatever four documents you are getting, how is your LLM or response matching with your context? This is what will do context relevancy. Answer relevancy is nothing but whatever question you have and whatever response you get, are they relevant? This is what answer relevancy will do. Then you have groundedness. Groundedness will generate few question and answering from your data, and then it will match with your AI response. So these are the three evaluation metrics that we have, and you can run all three of them using get, rag, triad evals if you just want to run specific of them. So in most of the use cases, what happen in deep learning, you have accuracy, you have precision, you have recall. It depends when you need to use which metric. Same in LLM as well. So in this use case, answer relevancy is more required because you are just talking with your YouTube video, getting the response. You just have to compare your response and question. This is where you can directly use get answer relevancy. If you want to have a very large context where you have 1,000 documents, whether my response what I'm getting is from that particular document or not. This is where context relevancy is more better in this choice. So based on business use cases, there are different metric which is involved. So you can use this metric by running your pipeline. So this pipeline will take care of your evaluation. It will take care of your AI response. So this is what you can do with RAG. It's very simple.
Okay.
Yeah,
So
same slide.
there's a question being asked, and after that you call the pipeline. Okay. So how does that k value comes into the picture? You mentioned k as 4, and like there are 1024 chunks that you have taken. So basically you are saying that you need to take 4 chunks at a time. So how does that retriever in the pipeline knows that whether we should take 4 or not? Is 4 the right number? I didn't get that logic.
Okay. So k, when you define top k to be 4, your this retriever already has only 4 documents. It's not about this part. It's about only this step. So when you define top k to be 4, your whatever documents you have in your vector DB, your query, whatever you are asking, is that function is written here. But here my only step is to pass that object. So here what is happening is I'm passing the object which has my retriever, right? Whatever re-ranking you have done, whatever k context you have done. So this will pass that retriever. Here once you ask the query, there is a function which will be triggered inside generate model. So what is that function? We have get relevant documents, right? So here you have just the object. That object based on user query you get, you are running it inside generate. So that we are running this pipeline parallelly. It's not dependent on anything. No. So 1024 in, yeah. So if you have 1024, 4 chunk in the sense it will be 4048. So it's like a document, 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 document. It's a schema that you define. Yeah, into 4, 4096. So this is prompt engineering. So far there are libraries like Ragas, there is library like TrueLens, and we have Beyond LLM. If you look at their code base, internally for context relevancy, answer relevancy, they are using a LLM to evaluate. It's like for LLM, if you give instructions, right? In recent days, that's what I was telling in the beginning. The underhype of what LLM we are talking about, if you were there in the beginning, that underhype is what agents. People are unaware of what agents can do, because once agents understand how you can reason, how to take action, it will be next level. So in order to execute agents, most important part is planning. Planning is where you are writing prompts. So the better you write prompts, the better result you get. Same here. All this evaluation metric, answer relevancy, groundedness, and context relevancy, we have written a prompt for that, where it will take your context, it will use some kind of functions. So basically it's just a prompt, but there should be little bit of engineering required, right? Like how you can get your context, how you can manipulate the tokenizer and pass it to your LLM as a prompt. So basically it's prompt. It will be a score. It will be a threshold score. Suppose if your context relevance is relevant to your AI response, it will be 8.0, it will be 10.0. With this score, there is a feedback message. So feedback message is just like looping condition. So basically, it's like a score you are getting. So the better the score it is close to 10, the better it is. If it is close to 0, you need to improve on that. 0 to 10. Right. So now RAG is just one part of what Gemini can do. Or I won't even tell one part, I'll just tell 1% of what Gemini can do. So there are other possibilities that you can perform. If in case you don't want to get into RAG, what are the other possibilities? We have multimodal. Multimodal is in the sense, suppose I take the image of it, and if I ask LLM what it is about, so it will give you a description of it. So the ability to understand images, the ability to understand the audio and ask the query, this is what multimodal does, where it is combining different senses. It can be audio, it can be video, it can be image. Image with text is what multimodal can do. So this is where if you go to this thing, right? Yeah, what Gemini.google.com. So now, before it was bar.google.com, now it is Gemini.google.com. If you upload an image and if you want to ask a query related to that, this is what multimodal can do. One of the uses can be education. In education, there are tons of physics notebook, biology, chemistry, and there are many concepts which is very difficult to understand, right? Teacher can't give you the better response. Teacher has limited understanding, or it might be very complicated to a student. Now let's take an example. There is a physics concept on any block diagram. Let's take a lens ray. Like, okay, lens ray is there, and you want to get the understanding from large language model based on your interest. So what I'll do, I'll go to Gemini, I will upload that image, I'll tell my interest is in cricket, explain me this particular block diagram in a cricket fashion. Once you get the response, you will relate to your interest, right? So again, in order to get your response as per your interest to your data which you are providing is what multimodal can do. And education is just one single piece or one single industry. There are so many other industry where multimodal can be used. So the best one is education. Then comes function calling. Whatever RAG we have, if you want to cut that RAG part, like suppose you have vector DB, store that in vector DB and all those things. What function calling will do is, you just have a single function, it will use a API. The better example is the tourist places, weather API, cricket. So now what will happen is, suppose you are building a ClickBus platform, ClickBus LLM, right? When I ask a query what happened in yesterday's match, give me detailed analysis. So in this detailed analysis, your large language model doesn't know anything about what happened in yesterday's match. So now what you will do, you will write a function which will trigger that ClickBus API. It will give you the context. That context you are passing to a large language model. So whatever function you are writing, which is triggering that API, is what function calling does. And this is advanced version of what RAG is. So if you can combine RAG and function calling, that's even more advanced. So function calling is what Google is doing now, and it was again first invented by OpenAI, but even Google is doing this. Now comes the very important part which I am working on, which is LLM reasoning, RAG and more. So LLM reasoning is nothing but agents, right? How you write agents. There are different framework. You have React. So what React does is, it's not your web development React. It's nothing but React for agents part. So this agent is nothing but you add a thought process. Let me give you an example of planning. Suppose if you want to build any software, right, for software application, the first thing is a product manager will give you the requirements. He will tell you what should the task be about. So first thing is get the requirements. Second is divide the requirement into 10 tasks. So once you have the 10 tasks, you are executing each 10 tasks. Then there is a human who will evaluate your 10 tasks. Then you will reiterate. So if you look at your life cycle of your entire software application, there is so much of loopholes. Like one needs to give the feedback, one needs to subdivide your task. So this decomposition, executing the task, is what LLM reasoning can do. So what you need to do is you need to write a proper planning. Based on your proper planning, you are using certain action. So this action is where you have your tools, external tools, which you are using in agents. And once you get this tool, you are devising a task creation. Then this agent will give you the task, or it will decompose your task. This decomposing your task, that is nothing but subtask of your main task. If I have to give you an example, I want to build the software app. What are the steps that I need to take? It will give you, you need to collect this data, you need to do pre-processing, you need to build a model, then you need to evaluate it. So there are 10 tasks that you need to do. So first thing is, you will use a LLM, you will design what task you need to execute. This design task is what you do planning. Then once you have this plan task, you are again passing to a large language model, which is reasoning it. How do I need to execute it? And once it executes, you are passing to another large language model, which will evaluate it. So this entire pipeline is what agents is doing, and this is where LLM reasoning comes, which is the ongoing research of LLMs. And then you have CoPilot. CoPilot, I don't have to explain this. If you want a code assistant for your code base, you can directly use Gemini or any other platform that is using it. So Copilot is again a sub part of what agents can do. So these are just few part of what Gemini can do. And again, normal question and answering is what all the large language model is doing as well. And this is about Gemini. If in case you want to learn about multimodal, so I have a detailed project which I have built. Again, this is again tourist place. I took some 20 images, then based on certain history of those images, you are not writing any RAG. What you are doing is you are just passing the images and you are connecting Gemini to it. That's it. And the link is Gemini Multimodal project.
So just moving, before moving forward, there are a few questions from the live audience. So Govind Disby is asking, does Google have a hosted vector DB like Firebase?
Google doesn't have any vector database as of now.
As of now, it doesn't have. Okay, go. Next one, he's asking like, so there is no free tier anymore for Gemini.
I guess they extended till May 14th.
After that,
Not sure.
not sure.
Last time it was May 2nd. So initially they defined it to be May 2nd. Yeah.
So like if we use any open source LLM like Level 3, is there anything to do with Facebook or anything? Like are they going to monitor us?
No, no, no. When it comes to open source model, let me give you the definition between open source and closed source. Open source is nothing but deep learning model what you have, those model weights are available online. So when you fine tuning, you are just using those weights and you are building a new model. This is what you mean by open source. Closed source is nothing but whatever model weights you have, it's not given it to any public. So that you can't use those model weights and build your own model. So weights is very important when it comes to deep learning models. So I don't call it as AI model, I usually address it as deep learning. Why? Because you build models in deep learning.
Okay,
So
like you tested Llama 3?
Llama 3 is open source, right? You are not paying money for it. It's already available on Hugging Face or it's available on GitHub. You are just using those model weights, you are building your new model. But the downside is you need to have compute. So what Meta does is they just release the model, they have the infra and they are giving you whether you want to take it or not, it's up to you, but people who are using it, right? Because they have compute. If you have GPUs, use those model, build your own model. This is what we'll do in next section, where you are fine tuning your own Gemma model, which is open source.
Yes, sir. Thank you.
Yeah.
So next question is, how do you re-rank or train something to re-rank specific to your business use case? Is there anything you played around with before a reference project?
So re-ranking is where you have Cohere. There are two things that you can use. Cohere again is closed source. They have not released their model for re-ranking. Then you have something called as cross encoders. So cross encoders is a sentence transformers library from Hugging Face, and they have models like rank GPT. And using rank GPT, you can re-rank them. Now coming to the question of have you played around it with? Yes, I have played around with it. And in these slides, if you can see, scan PDF Langchain hybrid search, and then again you have advanced RAG Langchain and Hugging Face. So in these two particular videos, I have done live coding where you can implement RAG using re-ranking in detail, which is using Cohere. And in Beyond LLM, since we wanted open source thing, we have used cross encoders. And just to give you more context, apart from cross encoders and Cohere, there is also something called as flag embedding. Flag embedding is again a technique which is used for re-ranking.
Okay, there is another question from the CEO of Start Automation, Mr. Anup Ambika. He's checking like, would RAG augmented LLMs take care of the data privacy issues that exist with the current enterprise LLMs?
Yeah, so what happens is we have faced the same issue when it comes to finance domain or when it comes to banking domain. Data privacy is one of the major issue, right? Because you don't want to use any APIs. So this is where what you need to do is you need to have a self-host platform where you can load your model locally. This is where instead of using any closed source model, you are supposed to use open source large language model. Keeping that in mind, this entire playlist, if you see Hugging Face everywhere. So what we need to do is, if you want to have data privacy issue in mind, you need to use a large language model, which is open source. You need to use a vector DB again, which is open source. Why? It gives you the flexibility to store your data. So if you use Qdrunt and Meviate, which has cloud service, you are giving or storing data on their premise. So in order to give you flexibility, you can use your own infra, where you are defining your own vector DB, which is open source. You are defining your embedding model, which is again open source. Large language model, which is open source, where your data privacy issue is not there.
So we use Gemma or Llama
You have
3.
Mistral, which is very powerful. You have Gemma, and again, since it was mentioned use cases specific, there are different open source model which are for FinGPT, like FinTech's GPT. Then there is medical GPTs. So based on your need, there are tons of open source model available. So when it comes to base models, we have Gemma, we have Mistral, we have Llama. Yeah.
So like when we are locally hosting our machine, means those all LLMs, how they are going to monitor the accept, like how they are going to enforce the acceptable use policy of those models?
So policy in the sense, suppose when you have the models, right?
Yeah.
Most of the model has that privacy policy thing, but most of the models doesn't has that policy. You are directly using their weights. So meta model, they just ask you to approve something. But whereas Mistral, Zephyr and all those things will not ask you with the privacy thing. And how do you load this locally? There is a model called Olama. Olama is a library. What it will do is, whatever open source models you have, you just have to pull those files. Like if you are aware of the concept called Docker, what Docker does, it creates a container within your system where you can spin up the servers and all. Same thing in Olama, what you are doing is, you have model files which is available somewhere else, either on GitHub or on Hugging Face. You are pulling those model files, storing that locally. So you have the flexibility of where to store that model. So you have the flexibility for that, and it doesn't matter on the policy part. And when it comes to Llama 3 models, you are supposed to write some kind of authorization. So this is where you are supposed to use those tokens, Hugging Face tokens. So that's about that part.
It's like if we violate the acceptable use policy, how they are going to terminate the access, since our model is
Here
already
you
on
don't have that thing. Like in Olama, it's not there, the termination part. In Olama, what I mentioned, right? The termination is not there, as what I'm aware of.
Okay.
Okay, so
So there is one other question. Since function calling is mentioned, does Google have a YAML data extraction method? Since YAML is more token efficient, as was founded by the LinkedIn in their report.
Function calling, mainly what I've seen is just you're calling certain APIs, and function is nothing but it's an additional parameter for your large language model. If you have a YAML file, whatever happens, the end goal is just to pass your data within that function. So it's like whether you use API or whether you use normal Python programming in between your function, that depends on you. So that flexibility of function calling is just a normal function.
And what was the optimal number of agents you found to get things done when chained? Read from a paper that it lies between 4 to 7.
You mean the maximum iteration of the agents, or?
Yeah, the optimal number of agents you found to get things done when chained.
Okay, so if he is referring to Crew AI, so Crew AI is a framework which is used to build agents. So you have agent 1, you have agent 2, you have agent 3. So it's like, if I have to give you an example, I want to get the location of Elon Musk. So first what agent 1 will do, it will research on who Elon Musk is. Second, it will try to understand where Elon Musk lives. Then it will go much in detail. So again, this depends on your use case. And one thing is, how many times are you supposed to run that planning? In few of the frameworks, there is maximum iteration, and the default maximum iteration is 15. 15.
Not 4 to 7.
That 4 to 5 is the agent definition.
Okay.
How many time it iterates, and iterates is nothing but how many time it iterates your prompt.
Okay.
That's 15.
Okay. So he was mentioning about the data extraction since it was related to the topic. Okay.
So data extraction, we can use Serper API. So in agents, right, you are supposed to give tools. These tools is where you can use APIs. If you want to build a CoPilot, you will use a GitHub tool or GitHub API. If you want to do the data extraction part from web, you can use Serper API. So based on your need, you need to specify the tool.
Yeah.
All right. So this was for the multimodal project. And again, to address the data privacy issue, most of the time what happened is I've given talks on RAG. Previously, I used to use OpenAI, but not many people has OpenAI access or Gemini access. I started building RAG application using open source model, where you're directly calling your Hugging Face. So if in case you want to learn RAG in advance, like hybrid search, re-ranking, then how to get faster response with streaming and all, you can probably check out this playlist. And yeah, so this is the end of the slides. We have the open source model beyond LLM. We have cookbook where you can use different models, different re-ranking techniques, or different evaluation metric. So the model name again is beyond LLM, which is the repo name, and it is available on GitHub, and the link is beyond LLM bit.ly. And if in case you want to get the access of the slides, so you can use this link, rag Gemini talk, and you can get all the slides what I've used here. Yeah.
Okay, so right now I'm going to ask an advice from you, okay?
Yeah.
So I have almost like 10 years of experience. Next year I'm going to have like complete my 10 years. And for me, the reason I learned AI is purely survival. I won't even say survival, just as a fun. Like I started off with the basic models, the linear regression, random forest, LSTM. So later on, I got a chance to use those models in the projects that I'm working on. And right now I'm a data analyst. So whatever I do is purely for the project or the business that I'm part of, okay? Outside the box, I don't get a chance to explore or adventure on the AI models. So suppose I want to start somewhere, where should I start?
I'll tell look into Kaggle. The reason being is, suppose if you want to learn something, you need to know how to write program, right? How people are writing. This is where I'll tell you my journey as well. So in lockdown, I tried literally every single domain, whether it is web development. I come from electronics background, so I used to do hardware, everything. When it comes to AI, Kaggle platform has around 1 lakh notebooks. So it's like, as you told, right, linear regression, random forest. What is the base to get your data? And data set, open source was Kaggle during that time, even now. So once you have the data set, how do you write a model, and whether that model is better or wrong? How do you evaluate it, or how do you get that understanding? By seeing how other people write. So I used to go to Kaggle, get the data set. I need to go to the notebook column. I used to download 10 people's notebook. I used to refer how they used to write. Now that's one platform, Kaggle. Now coming to the advanced, like now we are just talking to machine learning. When it comes to deep learning, there is deeplearning.ai. You can probably get the short courses, learn deep learning, and best thing is get your basics strong. And
Okay. The problem is my creativity is on a saturation point. Okay. So like on an application level, or like what should do you have any suggestions? Like on an application level, if I want to explore more ideas of how AI can be used, how can it?
okay, you can go to Hugging Face Spaces. So what Hugging Face Spaces does is you have all the projects which are available, whether it is multimodal, whether it is normal text-based models. So when you go to Hugging Face Spaces, you'll see what are the different projects which have been built in the AI space. And it's not just focused on deep learning or ML, it's also focused on advanced AI, right? Whatever you are seeing, generative AI. So one platform will be Hugging Face Spaces. Again, Kaggle will always be my first choice. The reason being is you have each and every notebook, whether it is on generative AI space or whether it is on normal this thing. And the thing is, you have challenges. Okay, so you have the challenges. Take part in those challenges. The reason why I'm telling you to take part in the challenges, you will get the real-time understanding. Whatever challenge you have on Kaggle, you have the data set which is already public. You have the competition which is ongoing. The better you perform, the better result you get. So this project-based learning, whatever you call it, in open source, why did I get into open source? Yeah. So the reason why I got into open source was to see how people are writing and get the idea of how they have built the entire uh, repository. So the way you learn from other people writing, the project-based learning is the best choice to get into AI.
Okay. Yeah.
Kaggle and Hugging Face.
So I suggest everyone to scan this and provide feedback to Google, because Google
Yeah,
for
yeah, Google.
developers, they actually ask like they all, would like to get the feedback on this.
So if
So
this is
please do.
not working, then you can probably try this goo.gle feedback form. Okay, so for LLM Indic language, there are few, you have a base model, right? When it comes to base model, it already understands few languages like Hindi, Kannada. If you want to make it very domain specific, like you have your own data which is completely in Hindi or completely in Malayalam, what you'll do, you'll just take that model, you will train the tokenizer part. So at the end, what does it matter? You have the tokenizer, which is in English. You have to train the tokenizer, not translate. There are different algorithm like one is byte pair encoding, one more is word piece, and one more is unigram. So these are different tokenizer on how you can train. Even if you don't want to train the tokenizer, just use the base tokenizer. It understands English. So what is tokenizer? You have a word, that word it needs to understand. But if you want to understand the entire length of what your data is about, you will have those tokens already available in your base model, which is Gemma. So you can just use that base model and fine tune based on your data. So this fine tuning is what we'll talk in the second talk. Yeah, you have Lava, LLAVA. Open source from Google, it's not there on multimodal side. Apple has one, FET something.
Then on that Google's event, launching event on Gemini provision, they shot the video like in real time they are doing all these things, something like that. Like in real time,
They are recording what is happening in that sports video, right?
I think they are showing something and in real time, and if we can we can give the prompt in real time, and it will give us output like what is needed in that particular video, something like that.
So it's using Gemini in that video. They are not.
Provision, provision.
I'm not. Yeah, Gemini provision is not open source.
No, no, I'm not talking about the open source thing. I'm just talking about that particular video on the launching time. What I'm saying, I think like, can we? do this thing in real time? I tried many times, like
Yeah, in real time it's possible, but I have not explored that much of multimodal. Uh, I just know the models which we are using, like FPT is one. Real time is like how you utilize your compute, right? This is when it comes to real time, data scientist as just part of model building. How you scale it, how you do parallel processing is what MLOps people needs to think of. So it's like, is it wedge? This is wedge, right? So that real-time thing on how you need to pre-process is what MLOps team needs to find out. So usually we don't work on that part. My part is just building models.
for example, if we are planning to start a startup or something, can we use these and we try some fine tuning or something like that?
So
Can
it
we use
depends on your use case. Suppose fine-tuning can
can we
only
use those models without any permission? So should we take any permission?
see open source model is like when you fine-tune, right? You have your own model, right? When it comes to your own model, it's yours. It doesn't.
What about we made something using
See, data
Gemini prompt?
privacy will come on data, whether you are taking data from some third party or not. But if you are building just a model, I don't think that's an issue.
Then what about this Gemini Pro? We are using a Gemini Pro Vision or something for Google models.
I didn't understand why Gemini Pro.
I mean,
Yeah, we'll check.
the thing is that I'm doing my MTech in GitHub,
Okay.
and I'm planning to build software. The problem is that I tried many times, but I want to make this thing in Malayalam. This is like the problem. And I tried with Gemini initially, and I got some, it got very well. But after it was in February, they said that API key is not working correctly. So we
Regarding are you using some Google Translate API?
no, no, no. I just mentioned that I was saying about that Retrieval.
English version of
English version of Gemini.
before it was bad, right?
No. I started my project after Gemini's launch on December 30th, right?
So I didn't understand. You are using a Translate API.
No.
So you are using English version.
So it's a pizza break for those who are watching live. So we will be back soon. So how many of you have already implemented something in RAG? Is there? Okay. Okay, good. So how is the session going? So this is an open interactive session. So more questions should be asked. I can see like that is answering all the questions, but you should be ready to ask dumb questions also. That if it is very entry level questions also, that is fine. Trivial questions is also fine because this is just getting connected to what it is. And later you can go and learn and form community and do things together. But normally FAYA session is just to bring people of similar interest together. So it is not just about listening to one speaker, but also connecting to each other. networking, finding people of similar interest, so that tomorrow or day after or after a week or a month, you can be in connect and get questions clarified, right? So,
So I have a question. So from my developer experience, so if there's a database, I used to store it in a cloud, right? So if I have a database, I create for users and store it somewhere in where every other can in production like in a production grade software, I'll be storing in the database in the cloud, right? So if there is a vector DB, so where I'm storing it? So in the model. Okay, so the free version is how to do it, like host it for free. Okay, thank you.
so ഇവിടെ ഏതൊക്കെ കോളേജിൽ നിന്ന് സ്റ്റുഡൻസ് ഉണ്ട്? How many colleges are there? Let me try. Which are colleges? See your college name. St. Thomas. Okay, St. Thomas. കാര്യവട്ടം College. Digital University. City. Only 4 colleges. Karyotam, Data University, St. Thomas and CET. Okay. And how many companies representatives?
Side or open trends.
Side or open trends. Okay. Enfin, okay. High Rene. Thoughtline, okay. Cubist. InvestNet, okay. Then SRS, okay. Standard Chartered Vita. Subramanian, okay. So how many startups are there? Okay. How many startup aspirants are there? Okay, great. Okay, good. So it's a good mix of crowd, right? So how many of you are here for FAYA Potential for the first time? Okay. First time. Ah. Okay, so as you all know that it is the 115th edition of FAYA Potential. This started in 2013. Okay, because we just normally say like we do not have a place where community happens in Kerala. Like there is no free open space where people can come together and do that. So we just thought like why should we blame on others? So let's start something so that people every month first Wednesdays people can come here and we can discuss on what happened in the technology world in the last 1 month. Along with that something trending that is something that we foresee that it is the future or something that would be beneficial for the future that will get curated and provided for discussion. So that has been happening for the past 11 years. And we have a lot of different communities formed as part of it, a lot of startups who emerged as part of these things. And there is something called in 50 hours that happens. So another in 50 hours is going to happen on June 29th. Yeah, in 50 hours is where you have an idea, you want to build it, but you do not know technology or you need some support. Just get to in 50 hours. The next 50 hours, one Friday evening, we come together. We start discussing on this thing and people can come and pitch their idea. Some ideas people vote like, I want to work on this product because there will be developers, there will be mentors. They will come and help you build your product. And it is your product, there is no other red tapes. You can pitch in front of real investors on Sunday evening. So 50 hours building a idea to prototype and then there is no say, that is you just take it and build it and you take it forward. Ideas are 100, ideas are very cheap. Any idea that is there will be 100 of people working on that idea at the same time. The problem space which you are working on, whether you are able to build that product and take it to the market and make it a viable business. That is the key, right? And the feasibility of building it and having a business viability is the key. Idea, you will iterate with different ideas. So whenever you are a startup, the problem space is the important thing. That is define the problem space and one idea you want to try it. So I will just give you some examples. Like there was around 10 years before, like on the first in 50 hours, there was one guy who was a college guy who came here. His name was Ajish. He came up with an idea. He want to get push notifications from shopping malls, which whenever he passed in front of a store and a push notification should happen to his mobile with an advertisement from that shop, 10% discount on shoes. So he came here. Then one developer called Aramal, he just mentioned like I want to build it, I will help you build it out, and using some beacons with triangulation he identified the location of the person and the push notification was sent. And end of the Sunday evening he pitched in front of the investors and Muthoot actually told like I want to invest in it. And they are the first unicorn from Kerala, open fintech, open neo banking solutions. So the 100 unicorn from India started from an in 50 hours here. Okay, so those people come back and help you out when support you want to optimize your product and all those things. So this has built an ecosystem where there are hundreds of people who are willing to share knowledge for free, willing to help you out in your product idea and build it for you for free. Because just the thing is, we want more technology products to happen from our space because we have immense potential, but many of the times we do not aspire for building those type of things, right? So aspirations has to be improved. For that, we need a supportive ecosystem, and that is what we have been trying to build. And as of today, you have also heard about MuLearn. How many of you know about MuLearn? Yeah, okay. So MuLearn, there is around 33,000 plus students across the state. Part of that network, that is who is coming and coming with their affinity space. That is, they can come and learn and connect to the industry people based on their area. If they are interested in movie making, they can get connected to the movie industry. Dulkar's foundation is there. They will be doing workshops on that. Everything that happens in the system is free and open. So in Kerala, there is a model that is being created where that free knowledge sharing ecosystem is being built where you will have access. So access is the biggest problem here. Like normally we say like you do not have access to come to Technopark when you are students. Right now you have access, right? You can come here. You can connect to the people and see like what is happening in the industry. It is not like just like one day industrial visit that happens at some point of time and you just go out to Goa and enjoy and come back, right? So it is to connect with the industry and then getting that access. And then I would like to thank the Google for developers coming forward and requesting like, shall we do a session together? So we want to have a AI conclave. Then we just thought like, let's have one session before that on RAG, because that is something that is very relevant. And thanks a lot to for Tarun coming down from Bangalore. I think today morning he reached and he'll be here one more day. And then and he's a very passionate community guy, that is who runs a lot of programs, as well as everyone follow his YouTube channel. I think you're on a YouTube channel. New. Yeah, it's very new, but there will be a lot more you can expect from him. Now, after getting to what RAG is, so we heard about Gemini. So there is also Google coming up with an open source model, that is Gemma. So we know that Meta came up with Llama 3 recently, but Microsoft is still in closed.
Yeah, they have 5. 5.3 mini.
Yeah. So let's see like how can we use Gemma and fine tune it. Yeah.
I have a demo. Yeah, I'll make it up. Okay, so RAG was one benefit. So I hope everyone are done with the break. Okay, so yeah, this is alternative for RAG on how anyone can use open source model. Okay, so RAG, basically what RAG is doing, it's just passing the knowledge to a large language model. But just passing a knowledge to large language model is not always a solution, right? If you want to get better result again, you have to train that model itself based on your needs, right? This is where fine tuning comes in. And in this or in this talk, we'll mainly focus on how you can build your own model given that you have a base model. But what is this base model, how do we fine tune it, and what is the intuition behind it? We'll go step by step again, and I'll explain you how you can fine tune your own model. All right, so before we can proceed, how many of you have heard about Kaggle? Most of you who have worked with data science project or ML project might have come across Kaggle at least once. If not, you might have heard about Kaggle. And most of us might know Kaggle because of the data set that it provides. It has so many data set that we can use. If not, because of the challenges, that we can be part of the challenge and get inspiration from how other people are writing code. This is what I did. If I have to tell my entire journey, I did only Kaggle. I only copy pasted what other people used to write. And then somehow I started learning things and I got into this space. So the starting point was Kaggle. Because of Kaggle, I learned few things. Why? Because I know how other people write code. I took inspiration, and then you can create something of your own. Right. Now, one thing is, most of you know about Kaggle notebooks. You know about Kaggle dataset. You know about Kaggle challenges. But how many of you have heard about Kaggle models? No, right? So, just like Hugging Face, there are so many open source model. You have the model files. You have the weights for that model, which is open source. So most of it is there on Hugging Face. It's there on GitHub. So what Kaggle does is they have added the support on their Kaggle platform as well, where you can directly use these models. And these models is what I'm talking about, Llama 3. So there are so many players, right? You have Google, which has Llama, Gemma models, and you have Meta, who has Llama models. Then you have Microsoft, they have PHI, which is a 3 billion parameter model. And they have 4K context length model, they also have 128K. And surprisingly, it's very close to other models as well. So we'll mainly focus on Gemma. There are so many models out there. And when it comes to Google, you have Gemma model, which has two different variants. One is 2 billion parameter model, one more is 7 billion parameter model. But whenever you want to fine tune, you have the base model. But when it comes to chatting, like if you want to get the touch of, okay, you have a model, I need to have chat based interface. So this is where you have instruct. So if you have heard Google Gemma 7 billion, it also have Google Gemma 7 billion instruct. You have Gemma 2 billion instruct. So instruct based models are nothing but it's used for normal chat based interface. And the same thing goes for Mistral. Mistral also has instruct based model. Llama 3 billion also has instruct. So when it comes to instruct, it's like for normal specific use cases. It's like you want a chatbot, and if you want a chatbot for any application, you're not using the base model, rather you are using a instruct based model. Why? Because it has conversations. So we'll use Gemma and we will fine tune a coding based LLM. But before we can fine tune our own LLM, let's understand what is fine tuning about. Why is fine tuning different than RAG? So since most of you are from Kerala, you might have watched a movie called Robot, right? Rajinikanth's movie, right? So in that movie, there was a scene where he's taking a book, is memorizing everything, right? So what is he doing? He's already very advanced level robot. He has so much of data, but still what he did, he took the data, he's reading it. Why? He should have that context, right? He should be already intelligent to understand the data. So when it comes to fine tuning, whatever robot you have, it's trained on specific general purpose data, which is commonly used everywhere. But again, when you have a new data, if you are feeding it to a large language model, it needs to learn it. So this is where what happens is whatever robot or base model you are feeding in your data. This data again can be in any format. It can be CSV, it can be PDF, it can be raw data. Once you get this data, you are feeding it to a base model. Base model is nothing but it is already trained on specific data, right? You are feeding in a new data and you are training it on a new data so that it's a fine-tuned model, right? Now he has a smile on his face. Why? He's been trained on additional data which he never saw before. So how does it work? Now that you have the understanding, in simple terms, fine tuning is nothing but you have a base model, you are adding the data to it, you are fine tuning it. And this is different than RAG. The reason being is RAG is knowledge transfer, whereas fine tuning is you're imposing a language to learn the traits of what you want to learn, that particular slang. If you want your model to understand the slang of what your data is, you need to train in that specific way. Whereas in RAG, you are just using the base model. You're not teaching the slang of your data. It's like you get the context, you're doing the prompting, you're getting the response. Yeah, it's like if you want to have that understanding, like suppose we are a student, right? We get the classwork notebook, we get the context, we learn. But if we want to memorize it, we have to feed that entire data into ourselves and understand how to write.
have physics. So if you take science as like the LLM, we can make the science LLM be more specific to physics. And even if we fine tune it more, we can make it like thermodynamics. Like
Yeah, lesser
specialty.
specific.
So domain
So it's
field
like domain
specialty.
specific. If you look at the third point of the issues of large language model, the third point was domain specific contextuality. So that contextuality with RAG is just reducing it. Whereas in fine tuning, you are making it more advanced. So how does fine tuning even work, right? So we'll go a little bit of technical in this talk because it's been involved with the coding or open source LLMs. So when it comes to open source model, as I already told, the weights are already available online, right, or available on internet. So you have pre-trained weights. So this is your normal weights associated with your Gemma. Now what you're doing is, whenever your new input is coming, you are creating a new updated weights, right? So when you are fine tuning, you already have a base weights of your base model. Now what you're doing is when you fine tune, you also need to update those parameters. This is happening based on your new data. And the formula is very simple. Before you feed it to your embedding model, you need to update your weights. Every step of your transformers is where you will encounter with your weights. Like you have to update your weights in your each linear function. And the formula is you have your data, you have your pre-trained weights along with your updated weights. So remember this formula again when it comes to the upcoming slides. The same formula will be used with the updated version. In simple terms, you have the base model, you are bringing a new data, you are creating a new weight, you are combining them. That's it, simple as it is. Now, why do we need to fine tune? Again, it's very similar to what we spoke in RAG. The first thing is domain specific. This is the huge functionality or huge advantage of fine tuning. You are teaching the model what you want. It's like teaching something a slang or giving the benefits. In order to understand the behavior of your data, you need to fine tune a model. And then again, second thing is when it comes to building a model, right? As we talk about open source model, I can build my own open source model. Why can't I build the open source model? It requires certain compute. It requires the number of time you need to run it. If you think about open source model, you have 7 billion parameter model, 7 billion. So it's trained on that number of parameters and it takes huge number of time to train that model. And it's not just a normal data you're passing. It's like tons of data that you need to pass to a base model to learn it. So this base model again, in the backend, you're just using those transformers, architecture, flash attention, attention mechanism and all those things. You can build your own model, right? Why are you stopping? The thing is, it requires that much of compute. It requires that much number of training time. So more the compute you have, the training time will be less. But when it comes to fine tuning, you are not building your model from scratch. You are just using the base model weights and you're adding your new data. So your compute is getting saved because you're not training it from scratch. Second, the number of time. When it comes to fine tuning a model, I have built a model called Panda Coder. So it took me around 10 to 12 hours just to fine tune that model. So I'm not talking about building from scratch. I'm just telling building a fine tuned model took me around 10 to 12 hours. And there are few people who also do it for 70 hours, 100 hours just to fine tune a model so that they can get better to better results from their model. So this is where when you have to fine tune, you have to use lesser compute than building it from scratch and the time is also getting saved. Yeah.
Fine tuning is different from like retrieving data from previous queries.
Yeah, what happens in retrieving data, you're just fetching the data. You're not updating the model, right? What happens in fine tuning, whatever weights you have in that model, you're updating that weights. You're learning it. It's like you're training the entire LLM again. Whereas in retrieval augmented generation, you're just passing the context via prompt. Here you're not doing any training process. Here you're just doing prompting. If you want your model to understand the behavior, if you want without any data, if you want to your LLM to perform something, you're fine tuning. It's like training again.
Once again, so like my base model is going to stay away, means the data of base model and the data of fine tuning is going to stay separate.
So this is where how you fine tune the model depends. So there is something called as catastrophic forgetting, which I'll talk in my slides. So the way how much you train your model depends. So if you are fine tuning for your complete weights, there is certain time you can train it. So what you can do is the more you train, you can erase your entire pre-trained data, right? If you just want to keep your pre-trained data as well. So in most of the case, whatever fine-tune model you're doing, suppose you want to build a coding LLM. So you have a coding data set and you're using a code Gemma model. So code Gemma model, it already has different languages support. So you don't have to train for a very long time, or you don't have to train the entire parameters. You are only training it for certain time by using the existing knowledge as well. So there is a way, like you can use different parameters. Probably I'll talk on catastrophic forgetting and theft in the coming slide. That will answer your question.
As like you have any practical videos on fine tuning at your channel?
As of now, no, but I have few codes, code snippet. So I have it on Hugging Face. I also have it on my GitHub profile. I'll show you that you have 4 to 5 files. And probably for this particular session, we also have a code demo where I'll show you which particular parameter will affect on whether your previous data needs to be there or it should not be there. So this is something called as alpha by R ratio. You will understand this once I talk theft. So we'll go line by line. After theft, we have a code demo. I'll tell you what is the importance of alpha by R ratio.
So like when you are like building a model from scratch, you'll be giving a database for the training. Okay. So suppose at that time you get an accuracy of 75%. You will have another option of training it again. Like you already have a trained model, you can train with the other database you have to train it again to get a better accuracy of 78%. So fine tuning is something like that. Already you have a trained model, you just want it to focus on like the context that you have in the project that you're working on.
So we'll take the same example, right? You told science. In science, thermodynamics. So in your syllabus, thermodynamics is something different, right? Whereas in general knowledge, that model was built in some outside country. In India, thermodynamics syllabus might be different. If you want your model to understand what the thermodynamics is, you have to pass the data, you have to retrain it so that it understands that. So that's where fine tuning is mainly needed. In RAG, you're just getting what thermodynamics is chunk by chunk. So that's the difference. You are not training it in RAG. Right. So can you to fine tune a model? So far we saw that there are three advantages of fine tuning. One is the context relevancy, domain specific context response. Then you're not training your model from scratch. That's where it saves you lots of compute. If you're saving your compute, you're saving the time, you're also saving your cost, right? GPUs are very costly. If you remember when he showed that video, there was a number called 30 billion to 100 billion, right? They are running that much of servers, that much of cost is associated to run that model. That is what compute is. You just can't use that model. You need to have compute. So can you fine tune a model? This is where there is a Hugging Face space. The Hugging Face space is can it run LLM? So what it will do is you just have to pass a model name and it will give you different requirements. You require one GPU for inference. You require one GPU for full training Adam. So I'll come to what Adam is. Then you require one full fine tuning for LoRa. LoRa is what I'll talk next. So in this library, it will tell you what is the D type that you need to use and what is the compute that you need. So if you look at this one GPU, it can be T4 GPU, it can be V100, it can be E100. So what is the compute required to run that specific model? You can probably check out this particular Hugging Face space before you even fine tune a model. And now talking about what are the downsides of the model. One is catastrophic forgetting, which I mentioned. The reason being is whenever you fine tune, there might be a concern, should I keep my previous data or not? There might be chance where the entire previous pre-trained data might be erased when you fine tune. So this is where you mean as catastrophic forgetting. This is not just in LLM, it's also there in neural network. In neural network also, whenever you train your model for a very long time, you will end up into catastrophic forgetting. That means whatever previous data you have, it might be erased. And then again come computational requirements. Even though you are not using the base model, you are fine tuning it, you require a T4 or E100. Why? The model weights remains the same. if you are building a 7 billion parameter model, even after fine tuning, your model remains 7 billion parameter. You are not reducing the computation. It's like computation is getting reduced in building that 7 billion from scratch. So this is the compute, and then as I mentioned, you are building a base model. When you fine tune, the number of parameters is same, 7 billion, 7 billion. So this is where there is lots of research which went on, so that you can use parameter efficient fine tuning. So here, when I talk about full fine tuning, it's like you're fine tuning the same number of parameters. In the research, it says that you can reduce the number of learning parameters when you fine tune. So this is the concept of parameter efficient fine tuning. So in parameter efficient fine tuning, it was inspired by this paper, which is called as Intrinsic Dimensionality Explains Effectiveness of Language Model Fine Tuning. So what this paper says is, there is a intrinsic dimension. That means whatever weights you have, you can use the smaller dimension of the weights. So if I have to explain this in a very simple way, when you are building a neural network, I hope everyone knows neural network, right? Or heard about neural network. There is a concept called backpropagation. So what happens in backpropagation? You are doing a normal matrix multiplication. So when it comes to normal matrix multiplication, there is certain dimension of that particular weights. So what this paper tells is, when you when you fine tune, whatever these weights are there, it can be reduced. So this is what you mean by intrinsic dimension. That is using low metrics or low dimension matrix. So if your weights, right, whatever weights you have, when you do matrix multiplication, it will be 756 into 756, any number. I'm just taking in general. You are doing this matrix multiplication, right? This is the word 756. So what this paper tells us, when you use intrinsic dimension, you can reduce this number. It can be 100, right? So then what happened is, then came the LoRa paper. It took this in one more advanced level. It tells that whatever weights you have, not just weights, even the updated weights can have normal format. This normal is nothing but you have additional smaller matrices. This is where you have A and you have B. So what A and B is, they are low intrinsic dimension, or you can call it as, in simple terms, low dimension metric. Just for your understanding purpose, low dimension matrices. So what this does is, you have the pre-trained weights, same diagram as before, what I showed, if you remember these previous slides. So same formula or same architecture, you have pre-trained weights, which is W, then you have updated weights. Now you just look into the diagram which I show again. This updated weights is divided into two smaller low dimension matrices. So A and B here is low dimension or low dimension matrices. This R is your intrinsic dimension, which you are using for your matrix multiplication for back propagation. So simple agenda of LoRa is, you are freezing few layers. If you look at fine tuning for normal computer vision task, you have number of learning parameters, which is dense layers. So not every time you have to use the entire dense layer. You can freeze few of them so that you are not learning it again. So this freezing mechanism of freezing that particular dense layer is what can be done in fine tuning. Now what is this dense layer? In transformers, you have attention mechanism. In attention mechanism, you have K, Q, V. These are the query pairs. So in normal deep learning, whenever you train this model, these layers is what you call as dense layers. So these dense layers are total 7 when it comes to open source model. One is Q, Q projection, one is V projection, then one more is K projection, then you have 4 more: up gate, up, gate, down, and O. There are total 7, right? These 7 layers have been used in your open source model. So now what you are doing is, for each 7 layers, you are freezing few parameters so that you can reduce the number of learning parameters. Before it was 7 billion, now it is reducing it. Now what is the number for it? So this is the benchmarking. I'll just brief out in very simpler way so that you visualize it what is happening rather than just listening. Number of learning parameters. For the model that we are using is Llama. You have 7 billion, right? When you use full fine tuning, look at this particular board. When you do full fine tuning, before also it was 7 billion. After full fine tuning is also it is 7 billion. Now what you are doing is you are using LoRa. LoRa, I talked about layers. There are 7 layers, and there might be chances you are doing experimentation. Deep learning training model is all about experimentation. Which works better, you need to find it out. So there is 2 experimentations which have been running. One is you are freezing all the layers. All the layers in the sense K, V, Q, up, down, gate and O. You are freezing all the layers. This is the number of parameters that you have. It is around 20 million. So you can just see 7 billion to just 20 million. You are reducing the number of learning parameter using LoRa. And if you look at this thing, you are just freezing 2 dense layer, which is Q projection and V projection. And it is around 41 million. So it's like the more dense layer you freeze, the lesser your learning parameter is. The lesser you freeze your dense layer, the more number of parameters it is there. But the end goal is to reduce the number of learning parameters. And when this is done, there is one more concept I need to clear. When you are using LoRa, there is also a concept called no inference latency. So if you look at the third point, I mentioned no inference latency. The paper of LoRa, they have stressed this a very lot. The reason being is, whenever you update these weights and do the back propagation, there is no additional latency involved, right? Normally, whenever you do back propagation, there is some kind of training which is going on, and it is reducing the number of parameters. Whereas in LoRa, when this process is happening, backpropagation, there is no extra latency. Why? Because that intrinsic dimension, when you perform this matrix multiplication, you are reducing the number of uh, low dimension matrices. So this is when you multiply this, there is no additional latency involved. So you are just running on the latency which the model was already trained on. So there is no additional latency. So whenever we fine tune or whenever you train a model, the training cost or whatever you train takes an extra latency. Latency nothing but what is the additional throughput, what is the additional time it was taken. So that additional time is not there while training. And how does it perform? Same formula. If you look into the previous formula, it was h equals to wx plus updated weights x. Now what you are doing is you are using the same pre-trained weights, which is w, x, and you are updating your updated weights into b and a. And if you look into their open source PEF library, it's just 5 to 6 lines of code where you are updating this matrix multiplication. So it's a very simple concept. Yeah. So it's like it's a very simple concept but implemented in a very advanced way. Yeah, it's using that intrinsic dimension research. Now one thing you need to notice here, we only focused on number of parameters. It's good that from full fine tuning, we are using PEF, which is parameter efficient fine tuning. You are reducing the number of learning parameters. This is sorted. But one more area is not sorted, that is the size of the model. So if you look at the size of the model, even with PEF it is 8 MB. Even with full fine tuning, sorry. Alright, so usually when it comes to full fine tuning, your 70 billion parameter model has associated size. So if you want to reduce this size, it's nothing but you want to do the quantization. So quantization is nothing but whatever hardware requirements you have, you need to reduce the size as well. So the focus as of now with LoRa is you have the number of learning parameters, you are reducing the parameters, you are not reducing the size. Then comes quantization, you have LoRa and then you have QLoRa. QLoRa stands for same LoRa concept with quantization. That Q stands for quantization. And quantization concept is very simple. In our normal academics, you might have come across floating point, right? floating point, there is three concepts. One is exponent, one more is mantissa, and one more is sine. And usually it is represented in 32-bit, 16-bit, 8-bit. And these large language models are running on 16-bit. So if you look at Hugging Face, all this model, Llama, Gemma, they are running it on a 16-bit floating point representation. What LoRa does is, it does one quantization only. So before it was how much? 16-bit quantization, 16-bit floating point representation. LoRa does it 8-bit, right? It was only one quantization from 16-bit to 8-bit. How is this even happening? You have your weights. Weights is nothing but when you do matrix multiplication, you are getting weights. These weights is in floating point 16 representation. You get the maximum value from your weights and then you add your range. So when it comes to 16-bit representation, the maximum range is -127 to 127. If it is 32-bit, it will be 30,768 to 32,768. You might have come across when you learn C programming, you have this range. So once this range is defined, you will divide it with your maximum value. So the range is 127 for 16-bit. You will divide your maximum value 5.4, and when you multiply it with your existing weights, you will get this quantized form. So for this floating point representation, which is in 16-bit, now we are representing that in 8-bit, which is the quantized version. And the representation is integer 8-bit. So this is what is happening in LoRa. From 16-bit to 8-bit, one quantization. What QLoRa does is, it introduces three more additional things. One is, whatever 16-bit floating point representation of a model you have, it's doing double quantization. Double quantization in the sense 16-bit to 8-bit, 8-bit to 4-bit. So QLoRa helps you to fine tune a model just by using 4-bit of your floating point. How is this even possible? It's using double quantization, and also it has introduced a new floating point representation which is NF4. NF4 stands for normal float 4-bit. So you have floating point, you have integer, and QLoRa introduces normal float. So once you have this, they also have a optimizer. So if you remember in deep learning, you have optimizers, right? Same thing in QLoRa, you have a paged optimizer, which is reducing your computation cost for quantization. So these are the three things. LoRa freezes dense layer so that you can reduce your number of learning parameters. QLoRa introduces quantization so that whatever you are running on 16-bit, you are running it on a 4-bit. So the number of compute that is required is less compared to whatever full fine tuning you are doing. So these are the two native process. One is LoRa and one more is QLoRa.
If I lower the parameters, will the performance get lower?
So regarding the benchmarking, right?
Yeah.
What I showed the benchmarking. So there is a benchmarking called eval RNS. So in this eval RNS, there are few benchmarking: MMLU, then you have LRSWAG, then you have Vino grade, then you have one more something called as R challenge. So these are the few benchmarking that you do for models. So for full fine tuning, it was around 58 point something, and after using PEF, it was around 52 or something. It's not degrading that much, but obviously there is a bit of degrading.
So if I quantize a model, that means I need less compute power, less GPU power for running it.
Also, it is affecting your accuracy, right? I mean, it's not affecting that much. As I told, 58 to 52. So it's like that much of difference.
Can a model be both quantized and reduce the parameters? Both?
I mean, increasing accuracy and also reducing the compute.
No, like reducing the number of parameters and then quantizing it.
Yeah, that is what QLoRa is doing. Okay. So QLoRa is LoRa with quantization. So it's reducing parameters, it's also doing the quantization.
That is done like automatically when you run.
Yeah,
okay.
you have a library called PEF. I'll do the code demonstration. It's just 5 lines of code.
Oh, thank you.
Already 10 minutes past 7. So are you okay to continue?
It's just 3 slides with one demo, code demo.
Okay. Okay, yeah.
When it comes to fine tuning, there are 3 areas that you have to focus on. I told you, right, for Panda Coder, I had to wait for 10 hours. right? If you mess up this 3 step, which I'll tell now, you have to wait for 10 hours, then again train your model again. So I'll tell you what are these 3 steps. First step is having your prompt template right. So this is the Gemma model. I'll now focus on what is the prompt template that you are supposed to use for a Gemma model. So out of 3 steps, the first step is define your prompt template. The prompt template for Gemma is you need to use the special tokens. So when it comes to deep learning models or any models, you have special tokens. So these special tokens are nothing but starting token, ending token. If you don't define ending token, suppose I ask a query, there might be chances the large language model, it will not know when to stop. It will keep generating some kind of garbage value. For example, when I fine-tuned Panda Coder, as a basic prompt, write a Keras implementation using TensorFlow. It gave me the response. After response, it added more data or more code. So that extra code was not required. The reason why it didn't understand was I didn't give the end of token. So whenever you are building up pre-processing, right? I told you pass your data to a large language model. How will you pass this? There should be certain pre-processing technique. So whenever you do the pre-processing, whatever data you have, you need to pass that question inside your start of token. So the start of token value for Gemma model is start of turn. Then you need to provide this user. User is nothing but user is giving that question. Then you need to have model. Model is the response. And you have to close this end of turn. If end of turn is not closed and if you are not following this format, you have to train your model again. Each model, whether it is Mistral, whether it is Llama, whether it is Gemma, every model has the special tokens which you need to keep in mind. Right, and this is from the technical report. You can look at this technical report. Again, I'll give you the slides. You can click on this link. It's around 60 pages technical report. Around 30 or 40th page you'll find this. User turn, you need to mention user, which is here. Model, whenever model response will be there. And start of token and end of token, which is start of turn, end of turn. How do we use this? I'll show that in the code demo. Yeah, it's different. For Mistral, it is just S, and ending is also S. For Llama model, if I'm not wrong, it is INS. Then at INST, which is instruction. Then at closing also it is INST, but with the backward slash. Again, so for the alternative of RAG, for alternative of fine tuning, this is again RAG. You might have already scanned the QR code. And yeah, that's it. So if you, in case you want to get the slides URL, you can look into bit.ly Gemma Kaggle. You will get the all the slides. Gemma Kaggle, you will get all the slides. And this is the collab, not collab, Kaggle notebook, which we will look into the code demonstration for 5 to 10 minutes now. You can scan this QR code. Just confirm if you are able to open the Kaggle notebook or not, where you have the code written. I only told you one step. There are actually 3 steps that you need to focus on. One is what I told earlier, alpha by R ratio. One more is tokenizer and one more is prompt template. How do you define that? I'll show that in code demo. Is it done? Are you able to see the code? This is for slides. The slides for Gemini was RAG, Gemini talks. The slides for Gemma is Gemma Kaggle.
Fine-tuned LLM.
Okay. So now suppose you have a company which you are building. If you have a fixed data, if you know that this is the only amount of data I need, then fine tuning is the best option. When you know your data is fixed, there is no changing, or else there is very rare change, then you use fine tuning. But it is very frequent. Like suppose in 1 week your data is keep on changing. That's where you have to use RAG. In terms of cost, RAG is very cost effective because it's very less. Because you are just using vector DB and LLM that you are using. Yeah, with the context. When it comes to fine tuning, you have the cost of running that training the model. So it's like when you train the model, there is certain cost involved because you need to use EAN rates. And again, after you fine tune a model, you can only inference that with GPU. It's not that you can run your model with CPU. If you go now and run Gemma model on CPU, your laptop will crash. So what you need to do, training is also on GPU, inferencing is also on GPU. So the cost is more when it comes to fine tuning. Yeah, RAG is efficient, but if in case you have compute, right? Suppose there are multiple accelerator programs which are available. You train your model once, save it on Hugging Face, then I showed you the process, right? How you can load your model from Hugging Face. There are different approach. That inferencing is something you can reduce your cost at. So your model is stored somewhere. Then inference cost you are reducing it using with your Hugging Face or replicate is there where you can where you are hosting your model and using the APIs.
So as a developer, you are doing only RAG only, or are you doing fine tuning as well as a?
So
Uh,
in our case, since
yeah.
we have data which is updating very frequently, we are using RAG.
Okay. I mean, so on a regular basis, if you have to do RAG, would be much more
Yeah,
useful
yeah,
for us.
regular basis. When your data is like, okay, it's keep updating, and you just have to fetch your knowledge, fetch the data. That's where RAG is useful.
So if you like for each different case, say for a healthcare industry, you will be getting multiple images. You were saying about the images, right? So in that case, you use RAG or
No, no, when it comes to images, RAG won't be useful. When it comes to images, there is a multimodal that you need to use. Uh, Apple has a model called FET. If not, you can use Lava. You can fine tune these models as well. Once you fine tune the model, you can just pass the image and you are asking the query. So whatever images you are passing, right? That images is learning text encodings.
okay. I mean, like say like I have a say like 10 to 15 chapters of thermodynamics. I don't know anything about it, and I have an LLM. LLM has random knowledge, as you said earlier. So
Exactly.
in this case, you will use multimodal to pass all
If
the
you have
images.
images,
Yes,
if you have
images.
images, you'll use multimodal because multimodal can understand your image features. So there are three ways again here. One way is when you are fine tuning, whenever you pass the image, you can use a multimodal, get the text summary of it, then fine tune. If not, you can directly use this image and text. And there is a model called clip embedding. Clip embedding was developed by OpenAI. So what clip embedding do is it will combine your image and text and then create the embedding of it. So you can use this for fine tuning. So there are three different ways for this. Either you can do text summarization, combine them, or do it separately. Like
Yeah,
find
another use case I can think of is resume tracking. Resume, I mean, like companies get lakhs and lakhs of resumes. So as to filter the effective candidates, the candidates who are really good for the job. I mean, do you have a, I mean, like the comparison or something that can be done with multimodal only, or do you
yeah,
have to
it can be
use?
done with multimodal, but not with this approach.
Okay, I mean,
This
with
is only text based.
text based. Okay, I mean, yeah, fine.
If we can convert the Kansas resume into text, then it can be used.
Yeah, that you have to convert, right? That is pre-processing step. It's not model training step. So I'll go with the code demonstration. It will just take 5 to 10 minutes.
Yeah. Any other questions? We can take it offline after that. Yeah.
Okay, so I'll only focus on the three steps that I said. You have the notebook. There are tons of notebooks also available online. The three step is, we'll go line by line just to be on same page. We need to install libraries. One is transformers to use the open source model. Then we are using bits and bytes. Someone asked about the 10F4, right? Initialization of that normal float point that you can do using bits and bytes. So this is the library for quantization. Then you have PEFT. PEFT is for parameter efficient fine tuning to use LoRa. Then you have datasets. Dataset is nothing but I'm using a open source dataset, so I'm using that library. The very important part is TRL. So there are two steps that you can use for training. One is SFT, which is supervised fine tuning. One more is DPO, direct proximal optimization. So if you look at GPT, you might have come across proximal optimization algorithm. There was a image in GPT where it shows all the policy gradients training. So what happens in DPO training is you need to have data in such a format where you have content, you have chosen pair of answer and rejected pair of answer. Not every time you have this context. That's where in this case we are using SFT, which stands for supervised fine tuning. Now we are just importing everything. So we are importing auto casual LLM to call our LLM model. Then we are using this data set. And then we have LoRa config. LoRa config is nothing but initially I said about alpha by R ratio. Where are we defining this alpha by R? It's been defined inside your LoRa config. Okay, so the first step is bits and bytes configuration you are supposed to do, where you need to define whether you need to load your LLM model in a 4-bit or not, right? I need to load my LLM model in 4-bit so that I can perform quantization. The next thing is what is the format of it. So what was the format in QLoRa? NF4, normal float 4. And then quantization is true. Here one thing that you need to notice is what is the float point, compute type. So if you are using T4 GPU, if you are using V100, you need to give float 16. If you are using A100, you are supposed to give torch dot B float. You can keep this auto. Yeah, it will differ based on GPU.
Okay.
For A100 it is B float. Here it will come B. For other
NVIDIA GPUs, right? Or will it support AMD also?
So A100, H100 it will support. You are just loading the model, and here is the first step. Out of the three, the first step is whenever you fine tune your tokenizer, whatever your last padding token is there, it should be end of token. Again I'll repeat, out of those three steps that I said, the first thing is whenever you are loading the model, whenever you are updating your tokenizer based on your data, the last token whatever you have, it should be end of token. If you don't give this, your model will not know when to stop. It will keep generating some kind of garbage tokens. So define this end of token, first step. Second step is LoRa alpha by R ratio. So alpha is the scaling functionality, R is nothing but intrinsic dimension. If this ratio is less than 1, you are using the data which was already available. You are not completely fine tuning. If it is more than 1, the alpha by R, you are completely fine tuning and you are ending up into catastrophic forgetting. This is where, as you asked earlier, right, whether my previous data will be there or not. This depends on these parameters. If it is less than 1, it will be there. If it is more than 1, you are vanishing it off. So this is the importance of alpha by R. And then if you looked at that benchmarking, I told LoRa all layers. LoRa only Q and V projection. So those 7 projections are K projection, V, K, V, Q, up, down, gate and O. These are the 7 dense layers in your Gemma, Mistral or other transformers model. So the 2 step is done. And
For now, the alpha by R is like 2, right?
yeah, it's true. I want to completely remove because I'm building my own coding
Okay.
LLM.
What if the alpha by R is 10? What difference does it make?
So
Will
it's
that
like
nothing?
usually, right, this is your dimensions. The more you give the dimension, there is no use of using PEF. That's where if you see I'm just giving 64 and 32. If you give around 1024, your dimension itself is 756. What's the use of PEF? So that depends on your training, right? So if you want to use parameter efficient fine tuning, you are supposed to use less dimensions. So if you use less dimension, it will be in between 0 and 5. And I have not seen anyone using more than 2. So the ideal value, there is a blog. Those people are just using 1. Even for Panda coder, we have used only 1.
Range is between 0 and 2.
0 to 2, yeah.
0 to 2.
Ideal, it's 1. Okay, so now I'm just loading the data set. This is normal process. So this is just the data loading part. In your case, if you are using CSV file, if you are using PDF, this step will be different. But the major thing is this 2 cell. So the first thing is end of token you need to define. Second is alpha by R. Third thing is very, very important, which I also mentioned in slide. You need to give start of token. You need to define your user. Then you need to give instruction. So whatever instruction you have for that coding LLM. Then you need to give end of token. Then again start for your model. Then again end. So whatever data I have, it uses a format called alpaca style. Alpaca style stands for chain of thought mechanism. Chain of thought is nothing but you have instruction, you have input, you have output. I'll give you an example. I want to build a neural network using Keras. This is my instruction. Use cipher 10 dataset. Use cipher 10 dataset is my input, and output is whatever result you have. If you are someone who is learning DSA, you might be expert. You might see few instruction, you might see few input data, you might see few output data. This is what you need to define here, right? You can scrape entire lead code data. You can take the actual response, add it here, whatever instruction you have, right, that you can add it here, and whatever input is there, right, the sample input for this particular thing, use 1 comma 2 comma 3 array. So that is the input. So you need to format in such a way that you can add this. In most of the cases, as I said, write neural network code in Keras. That's it. I don't have input. So in that case, you are not giving input, you are directly giving instruction and output. So very important, make sure end of token and start of token and end of token is given in your prompt. If it is not given, it will again give garbage result. So these are the three things. Once you give all these three things, you need to define this Adam, and in your this thing, right, the diagram which I showed, can it run LLM? There I told for 1 GPU for Adam. What was that Adam? Adam is nothing but your optimizer. That's it. So once you define your training arguments, you have to run SFT trainer. In your SFT trainer, you are passing this prompt, which is your data. If you notice this, data set text field. In which field of data do I have my actual context? It is in prompt. And if I have to show you that, so this is the prompt. This is my text field prompt. The same prompt I need to pass it here. Probably as a beginner, this is an advanced topic for you, but make sure you keep these three things in mind, basics. For tokenizer and end of token, prompt template should be as per the prompt template of that open source model, where you need to define start of token, end of token. Alpha by R ratio should be 1 or very close to 0 or 2. If it is less than 1, you are using the previous data as well. And once this is done, you just have to combine it. So the concept of LoRa is to create adapters. So it will create adapter files. You need to merge these adapters to the base model so that you have your own coding LLM. This is what we are doing it here. LoRa is the adapter. Lower rank adaptation. It's an adapter. It will only give you adapter files. These adapter files, whatever freezing layers you have, you need to combine it with your base model. So this step we are doing it here. Merge model, merge and upload. This is the base model. Coding LLM is nothing but I am saving my model, whatever I fine tune inside coding LLM. Merge this. Once you have the model, push it to Hugging Face. And if in case you have any doubts in this, probably you can reach out to me. And there are tons of open source notebooks which are available out there. You can use those notebook to fine tune. Yeah, so that's it from fine tuning Gemma.
So do you fine tune this on your machine?
So we have Collab Pro. So Collab Pro has E100. And one more thing in Kaggle, right? You have different hardware accelerators. You have P100. P100 only gives you 15 GB of VRAM. You can go to Kaggle and use T4 2x. So in the sense you are using 2x T4 GPU, which is 15 plus 15, 30 GB of VRAM. If you are using quantization, what I did now, right? I am running it on Kaggle. So that's a 7 billion parameter model which I am running it on Kaggle without any giving any price. So it's free. So it's like you can only run it for 30 hours. After 13 hours, create a new account, fine tune model.
Okay. So, Tarun, as you mentioned, for any questions, please follow him. You are on Twitter also, right?
This is LinkedIn and Twitter.
So Twitter, and we are also thinking of adopting him to our community, right? How many of you want him in MuleLearn? So you don't worry. Just like that is, we will have you have a session or some boot camps that is we can run further, and then we can see how actually we could work together.
Sure.
Okay. So let's officially conclude the session. And as a token of appreciation, I just invite the FAYA POTT committee to hand over the certificate. And then let's have a photo together and close. Okay. Yeah. Yeah. Great. So that's the end of 115th edition, and next month we are expecting to have a bigger session on A, and it will be on 5th of June. So that marks the 11 years of FirePort 80. Okay. Yeah. Okay. And let's have a photo together, quick photo together with the speaker. Yeah. So photographer. Yeah. You just take the picture from there. Tarun, you come here. Yeah.